Okay, division of fractions. Now, before I give you the rule, or before we see what the rule is, I want to motivate it. If you have any number, and you divide it by 1, you get back that number. If you have 7 and you divide it by 1, you get back 7. If you have 5 over 8 and you divide it by 1, you get back 5 over 8. If you have any number, if you have 2 to the 17th, you divide it by 1, you get back 2 to the 17th power, whatever that is. If you divide a number by 1, you get back that same number. Okay. Now, what would you multiply, say, 2 over 3 by to get back 1? The answer is 3 over 2. Of course we know what 2 times 3 is, but let's make believe we don't for a moment. 2 times 3 is some number, but isn't it the same as 3 times 2? Whatever that is. If you divide the same two numbers, you get 1. If you divide the same two numbers, you get 1. If you have 72 divided by 1249, well, if I multiply by 1249 over 72, now most people have no idea what 72 times 1249 is. And I'm on top of that list. I have no idea what that is. But I know one thing. It's the same as 1249 times 72. 7 times 9 is the same as 9 times 7. 72 times 1249 is the same as 1249 times 72. 72 times that number is the same as 1249 times 72. It is the top number and the bottom number. They're the same. When you multiply 72 by 1249, you get one single number. When you multiply the two numbers in the denominator, you get one single number. Coincidentally, you get the same single number. That is, dividing the same two numbers and you get 1 every time. You definitely don't want to say, oh, 1249 times 72 and work it out and then do it again for the bottom. It's 1. The fraction is 1. You don't have to know what 1249 times 72 is. Yeah, 7 over 13, and you multiply by the reciprocal, you're going to get 1. Because whatever 7 times 13 is, I think it's 91. The bottom is going to be the same. 91 over 91 is 1. Don't bother doing the 7 times 13. Okay, if you multiply any number, you have any number, let A and B be, let A be a number and let B be a number, whatever it is. If you multiply it by B over A, well, the numerator is going to be AB, the product of A and B, the numbers that I'm disguising, that I'm not telling you what they are, and the bottom number is going to be A times B. The top number is A times B, whatever that is, and the bottom number is B times A, which is the same as A times B. The top number is AB, the bottom number is AB, 1. So, if you divide by 1, you get back the number. If you multiply a number by its reciprocal, you get 1. And we want to always, when possible, we would just love to divide by 1. Because it's a simple division. Don't do it. Any number divided by 1, don't do it. Alright. If you were asked to compute 2/3 divided by 7 over 13, like always, it equals itself. I want to change the way this looks. It equals itself times 1. Now there's many ways of writing 1. I want in the end that the denominator be 1. What do you multiply 7 over 13 by to get 1? Answer, the reciprocal, 13 over 7. Because whatever 13 times 7 is, whatever 7 times 13 is going to be the same as 13 times 7. You divide the same two numbers, that's your answer. But this fraction has to be 1. If 13 over 7 in the denominator is below this line, you better put 13 over 7 above it. So the numerator is going to be 2/3 times 13 over 7. Divided by 1. Oh, I'm an expert in dividing by 1. Don't do it. You get 2/3 times 13 over 7. That happens to be 26 over 21. But I'm more concerned with that answer for right now, with that result. You have 5 over 6, it has a new column, and you're dividing it by 7 over 15. Well, like any fraction or like any number, this is a number. You can multiply by 1. Well, I want the denominator to be 1 when I multiply. So what do I multiply that denominator by? The answer is the reciprocal. If this fraction is going to equal 1, I put the same number on the top. I don't care if it looks friendly looking or not friendly looking, whatever goes in the bottom, I put in the top. And the top is going to be 5 over 6 times 15 over 7. 5 over 6 times 15 over 7. Divided by 1. That means don't bother with the 1. Up to, so we get this result. We want to see how we can go from the beginning to the end more quickly. You have 4 over 7, and you want to divide this by 9/2. You take the original number, which I am now writing down, and you multiply by 1. You multiply top and bottom by 2 over 9. 9/2 times 2/9 is 1. After all, 9 times 2 is 18, and 2 times 9 is 18. 18 over 18 is 1. The numerator is 4 over 7 times 2/9. And then I divide by 1, well, just ignore it. I get this. All right. Now, let's try to make you guys happy. Let's try to figure out how we could not do what's in red. That is, how can we go from here right to there? How can we go from this fraction right to there? How can we go from here right to this? And there's a pattern that keeps coming up. The numerator is right there. It didn't change. The numerator doesn't change. The numerator does not change. The division line. The division line. What do you know? It became multiplication. The division line became multiplication. The bottom numbers, oh my, they got flipped over. It's 15 over 7, here it was 7 over 15. The bottom number is 9 over 2, it is now 2 over 9. You keep, so what's the rule? You keep the top number. You change division to multiplication. And the bottom number gets flipped over. Keep, change, and flip. That's not a bad saying to remember. You keep, change, and flip. You keep the top number. Change division to multiplication, and you flip the bottom number. For example, this somebody asks you what is 14 over 6 divided by 7 halves. This number divided by this number. You keep, you change from division to multiplication, and you flip over the bottom number. And you reduce if possible. For example, 2 goes into both of these numbers 7 times and 3 times. 1 from a bottom number, 1 from a top number. 7 goes into this top number and that bottom number, 1 time each. 1 times 2 is 2. 3 times 1 is 3. Why did I stop there? Because nothing goes into 2 and 3 other than 1. You have 7 over 9, and you want to divide this by 14 over 18. You keep the top number. You change division to multiplication, and you flip over the bottom number. And I guess you're going to get 1. Because 7 goes into both of these numbers 1 time and 2 times. And 9 goes into both of these numbers 1 time and 2 times. And 2 goes into both of these. Every time I said both of these, 1 was from the top, 1 was from the bottom. 2 goes into 2 1 time, 2 goes into 2 1 time. 1 times 1 survive, which is 1 on top. And the bottom, 1 times 1 survive, which is 1. 1 divided by 1 is 1. What you could have done alternatively is to say, you know what? That's 7 over 9. If you divide, this is one number, and this is another number. And you're dividing them. If they're the same number, you get 1. Get over this. Doesn't matter what the numbers look like, whether they're fractions, exponents, logarithmic equations, or numbers. If you divide the same two numbers, you get 1. Trust me, this is a number. Log of 14.2. It's a number. It is not 14.2. And if you divide it by that same number, 1, somebody just has to tell me that's the number. Oh, that fraction is 1. This fraction is 1. Because if this is a number, and that's the same number, divide them, you get 1. 2/3 divided by 2/3 is not a problem where you keep, you change, and you flip. 2/3 divided by 2/3 is 1. You divide the same two numbers, you get 1. 2/3 divided by 2/3, 1. 1 has to become first grade level. 1. Done. And what if you have 2 and you want to divide by 2/3? If one or both of these numbers are fractions, you play the fraction game. You keep the top number, you change division to multiplication, and you flip over the bottom number. If you like to put a 1 here, fine. Those are two numbers, 1 in the top, 1 in the bottom. 2 goes into each of them. 1 time. 1 times 3 is 3. 1 is 1, or if you prefer, 1 times 1 is 1. Your rule for dividing by 1 is don't. The answer is just 3. You have 5 over 7 divided by 2. If one or both of these numbers are fractions, you play the division by fraction game. You keep the top number the same, you change division to multiplication, and you flip over the bottom number. The 2 is the same as 2 over 1. When you flip it over, you get 1 over 2. You cannot reduce from top to bottom, so you multiply the two top numbers, you multiply the two bottom numbers, and you say, that wasn't bad. That wasn't bad. sometimes you can figure out the answer without really even doing the flipping. Remember, when you divide by 2, you're sharing. Each of you get half or something. Well, suppose you have 7 things. 1, 2, equal size. 3, 4, 5, 6, and 7. I'm get rid of this. And you have 6 of these. You have 6 out of 7. It's probably not a nice example to give, but suppose you have a test with 7 questions, and you get 6 out of 7. That is, you got 6 sevens. And your teacher discovers that you didn't really do it on your own. You had help with your friend. You and your friend both got 6 over 7. So your teacher is going to say, well, you only get half of the grade. I'm going to give this half to you and this half to your friend. That is, it's 3 over 7. You can divide the 6 by the 2 and get 6 over 7. If you go to the pizza store, and it's a strange pizza store, they cut their pies into 7 pieces. And you say, pizza man or pizza person, please give me 6 slices. So you are now getting 6 slices out of the 7. And you have it planned that you are going to go home and share these 6 slices with your brother. Well, you're each going to get 3 out of 7. You have 12 out of 17, and you're going to divide it by 4. So you have 12 pieces out of 17. You're going to share those 12 pieces with 4 people, with 3 other people. Well, you're each going to get 3 out of 17. Just divide the 12 by the 4. Why is it working? I keep the top number. I change division and multiplication. And the understood 4 over 1, I write as 1 over 4. Well, 12 divided by 4 is 3. That is, 4 goes in here 3 times, and it goes in here 1 time. And you have 3 times 1, which is 3, over 17 times 1. You're getting the same answer. Here's a nice way of saying it. When one sees that, they're real good at this. They understand what's going on. So you have 20 over 25, and you're going to divide this by 4. Well, if you have 20 pieces out of 25, so you have this game that should have 25 pieces, but only has 20 pieces. And you need to share the pieces among 4 people. So, 20 over 4 happens to be 5. So each person gets 5 out of the 25, which happens to be reducible to 1/5. Okay, if you understood that, great. If you don't understand that, well, what you can do is keep the top number, change division and multiplication, and the understood 4 over 1, and flip over. And then you say, you know what? 5 goes into each of these numbers 4 times and 5 times, and 4 goes into each of these numbers 1 time. You're left with 1 times 1 on top, which is 1, and the bottom, 5 times 1, which is 5. Some of you think that equals 5. That's not true. I know it's not true. 5 times 5 does not equal 1. 5 times 5 is 25. Okay. I want to make one more point. This is a very important point, and you need to know this. If you don't know this, you really can't do division problems then. Possibly I should have done this at the very, very beginning. 100 divided by 10 divided by 2 versus 100 divided by 10 divided by 2. there's something called the main division line, and it's the longer line. It's the longer line. It's this number divided by that number. And 100 divided by 10 is 10. And 2 is 2. And 10 divided by 2 is 5. It's this number divided by this number. This top number is 100. This denominator, this number, this bottom number, 10 divided by 2 is 5. And 100 divided by 5 is 20. We did not get the same answer. Notice, 100, 10, 2. 100, 10, 2. The numbers are in the same order. What's the difference? The main division line. Old-fashionedly, we would write this here as 100 divided by 10 divided by 2. This one, using the old-fashioned symbol, would be 100 divided by this, 10 divided by 2. Division does not have the associative law. You can't move the brackets around. So, if somebody asks you, how much is this? You should say, you don't know. Because you don't know where the main division line is. I tried my very best to make the division line the same length. I have no idea what this is. If somebody wrote down this at any point, I would mark it wrong. Because it's meaningless. It's meaningless. It has no meaning. It has no meaning whatsoever. Usually, I would put an equal sign and say, what does it mean? I don't even know where to put the equal line. Notice, in the first, I put the equal line immediately to the right of the main division line. Immediately to the right of the main division line. Like if somebody asks, 7 over 0 is equal to, put the question mark here. Excuse me. You can put the equal here. What is that equal? Or what is 10 over 2 equal? I don't even know where to put it here. Do I put the equal here? Do I put it here? If you do this, you have no concept of main division line. Or you're just being lazy and don't want to write one of the longer lines. Okay, that completes the section on division of fractions. Good luck with it.